Antikythera Mechanism. Discovered in a Greek shipwreck in 1901, the Antikythera Mechanism is often called the world's first analog computer. Built over 2,000 years ago, it contained dozens of bronze gears that could predict solar eclipses, lunar cycles, and the positions of planets with remarkable accuracy. Scientists were amazed because technology of this complexity was not believed to exist until many centuries later. The device demonstrates that ancient Greek engineers possessed extraordinary knowledge of astronomy, mathematics, and precision engineering. Even today, researchers continue studying its design to understand how such an advanced machine was created using the tools available during the ancient world. Roman concrete. Many modern buildings begin cracking after a few decades, yet some Roman structures have survived for over 2,000 years. The secret lies in Roman concrete, which was made using volcanic ash, lime, and seawater. Unlike modern concrete that weakens over time, Roman concrete actually becomes stronger when exposed to seawater because new minerals form inside tiny cracks. Famous structures such as the Pantheon and many ancient harbors remain standing thanks to this remarkable material. Scientists are now studying Roman concrete to develop longer-lasting, environmentally friendly construction materials that could reduce maintenance costs and lower carbon emissions in modern infrastructure projects. Damascus Steel. For centuries, Damascus Steel was legendary for producing swords that were incredibly sharp, flexible, and durable. According to historical accounts, these blades could hold an exceptional edge while resisting breakage during battle. Their distinctive flowing surface patterns also made them visually unique. The exact manufacturing process was eventually lost, making the technology one of history's greatest metallurgical mysteries. Modern researchers believe the steel contained unique microscopic structures formed through specialized forging technique. Despite advanced technology today, recreating authentic Damascus steel remains difficult because the original methods and materials are not fully understood by historians or metallurgists. Baghdad Battery. In the 1930s, archaeologists discovered clay jars near Baghdad containing copper cylinders and iron rod. Some researchers suggested these objects, now called the Baghdad Battery, may have generated small amounts of electricity when filled with acidic liquids such as vinegar. If true, they could represent one of the world's earliest electrical devices, dating back around 2,000 years. However, historians continue debating their actual purpose, with other theories suggesting they were used for storage or religious activities. Although the mystery remains unsolved, the discovery challenges assumptions about the technological abilities of ancient civilizations and continues to spark scientific debate. Greek fire. Greek fire was one of the Byzantine Empire's most feared military inventions. This mysterious weapon could continue burning even on the surface of water, making it devastating during naval battles. It was often launched through bronze tubes mounted on ships or thrown in containers toward enemy vessels. The exact chemical formula was kept as a closely guarded state secret, and it has never been fully rediscovered. Historians believe it may have contained petroleum, sulfur, quicklime, or other flammable materials. Greek fire helped the Byzantine Empire defend itself for centuries and remains one of history's greatest examples of lost military technology. Archimedes Screw. Invented more than 2,200 years ago, Archimedes Screw was an ingenious machine designed to move water from lower areas to higher ground. It consists of a spiral-shaped screw inside a cylinder that lifts water when rotated. Ancient farmers used it for irrigation, while miners removed water from flooded tunnels using the same principle. Remarkably, the technology remains useful today in agriculture, wastewater treatment, and hydroelectric power systems. Its simple yet effective design demonstrates how ancient engineering solved practical problems using mechanical principles that continue benefiting modern society thousands of years after the invention first appeared. Inca Road Network. Long before modern highways, the Inca Empire built an extraordinary transportation system stretching more than 40,000 kilometers across the Andes Mountains. The network included suspension bridges, mountain stairways, tunnels, and carefully engineered roads connecting cities through difficult terrain. Messengers called chasquis could rapidly deliver information across vast distances using relay stations positioned along the route. Despite lacking wheeled vehicles, the Incas created one of history's most efficient communication and transportation systems. Many sections remain usable today, demonstrating remarkable engineering skills that allowed the empire to govern one of the largest civilizations in South America. Maya Astronomy. The ancient Maya developed one of the world's most advanced systems of astronomy without telescopes or modern scientific instruments. By carefully observing the sky over generations, they accurately tracked planetary movements, predicted eclipses, and created highly precise calendars. Their astronomical knowledge guided agriculture, religious ceremonies, and political decisions. Many temples were even aligned with important celestial events such as solstices and equinoxes. Modern scientists continue studying Maya observations because of their remarkable accuracy. Their achievements demonstrate how careful observation, mathematics, and long-term record-keeping allowed ancient civilizations to understand the universe with surprising precision. Egyptian surgical tools. Ancient Egyptian doctors used surprisingly advanced medical instruments thousands of years before modern hospitals existed. Archaeological discoveries reveal bronze scalpels, forceps, hooks, needles, and surgical knives that resemble many modern medical tools. Egyptian physicians treated broken bones, stitched wounds, performed dental procedures, and documented illnesses in detailed medical texts. They also emphasized cleanliness during certain treatments, helping reduce infections. Although their understanding of medicine was limited compared to today, many of their techniques laid important foundations for future medical practice. These discoveries show that organized healthcare existed far earlier than many people realize. Persian Qanats. More than 2,500 years ago, Persian engineers developed underground tunnel systems called qanats to transport water across deserts without pumps or electricity. These gently sloping tunnels carried groundwater over long distances while protecting it from evaporation under the hot sun. Vertical shafts provided ventilation and allowed workers to maintain the channels. Entire cities and farming communities depended on these systems for reliable freshwater supplies. Many qanats continue operating today, proving their extraordinary durability and efficiency. This ancient technology transformed life in some of the world's driest regions and remains an outstanding example of sustainable engineering.